Alright, so this video is going to guide us through basically finding the equation of a regression line using a TI-83 or 84. So we start off and we need to establish whether or not we should even do this. And you know, in our steps we talked about the fact of making a scatter plot first, but you know, with technology it's often just as easy to compare the correlation, because we can find the correlation so quickly, with one of these handy tables that have been created for us, like table I allows us to compare a correlation coefficient with a computed critical value very quickly. So there's not a lot of back algebra behind the scenes. So we start off here. We got a correlation coefficient of 0.972. We have a sample size of 1, 2, 3, 4, 5, 6, 7. So that means that my degrees of freedom would be 7 minus 2, which is equal to 5. So we come over to our table I, we go to 5, we come across, we're using an alpha or significant level of 0.05, so we come down and we find out that we've been established a critical value of 0.754. Well, when we think about our normal distribution and we think about critical regions and non-critical regions, so our critical region here would be 0.754, and our critical region here would be 0.754. So that's kind of like that, okay, yeah, let's move forward. We have significant enough situation. Well, our value that we're going to use is 0.972. So that's over here, 0.972. So we're in the critical region, so yes, we're ready to go forward. We should do our regression analysis at this point. So remember, that's our scatter plot could show us that too. We could see this visual relationship, but this is so quick when the numbers are given to us, and like I said, we're working on the concept here. So now we move forward, and this is where the calculator comes in. So we need to find a way to find the regression line. And you know, in the last video, we talked about, you know, there is a formula for this. I mean, you can calculate the regression line by hand. But you know, when we have technology, it's just so much quicker. So the process here is we are going to hit our stat key. We need to enter our data just like we're going to find our correlation coefficient. So we're going to hit the stat key. We're going to go into the edit, number 1, edit. Alright, I already have entered the data in, so you can see if you needed to, if you had to clear your list, you could go up on top, you could press clear, and that would clear the list, or you could just go down on top right here and you could press delete, 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 delete until it was blank in the L1, and then you go over to L2 and delete, 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 delete until L2 was clear. But we got our data in. Go ahead and get that put in, and we've already done that in previous videos, so that's why I'm assuming we can do this. Alright, so our next command is we're going to go back to the stat key. So back to stat, and this time when we go over to calc, we're going to go down to number 8. I'm going to arrow my way down to it so you can see what I'm looking for. Okay, so on number 8 we have linear regression. We have linear regression. We choose that. We press enter. We hit blank, blank, blank all the way down to calculate. And we've already seen this, haven't we? So we actually had found the equation of our linear regression line when we were finding the correlation earlier, but I didn't want to overwhelm you and give you all this information all at one time. So essentially what we got here is we're going to pull our A value and B value out of there. Don't forget that they want us to round our decimals to 3 decimal places. So when you pull that out, you're going to say your A value is going to be negative, excuse me, having some technical issues, negative 3.310. My B value will be 1.029. Alright? Next step, finding that equation and using that equation. So now we have the equation y prime is equal to negative 3.310 plus 1.029x. So we're going to use that equation. So let me take a little snapshot of it real quick. We're going to use that equation on our last step. And here we are. Because now what we want to do is we want to make a prediction with that equation. We want to take that equation and we want to predict what would happen if we had 70, in this case here, 70 fires. And so this is a great situation for us to kind of take a second and discuss something that we talked about, the future predictions or the extrapolation. I'm saying that word wrong. It'll come to me in just a minute. I'll get it right. When we want to make these predictions, what we want to think about is that look at your minimum and your maximum here. My minimum data value in this data set is a 47. My maximum data value is 84. If I use this data set to make a prediction for 100 fires, there's a chance, since that's outside of the scope of my data, there's a chance that my prediction will not be as accurate as it could be, because my data doesn't cover a situation like that. So when you want to be real careful about when you're making predictions from these sample sets, that you make predictions inside of what's inside the range of the data. So our answer right here, to finish this guy up, we take that 70 into this regression equation that we've created, and we insert it in for x. We take our calculator and we type this in. So negative 3.310 plus 1.029, close parentheses, open parentheses, close parentheses, enter, and we find out that our y prime would be 68.72 acres. That's how many acres that we would burn approximately if we had 70 fires based upon the data that we collected.